Section 5.4, midsegment of a triangle. By the end of this lesson, you should be able to identify properties of a midsegment of a triangle, and you should also be able to apply properties of a midsegment of a triangle. First, we should get started with identifying what a midsegment of a triangle actually is. And a midsegment is a segment whose endpoints are the midpoints of the sides of the triangle. So taking a look at this diagram, we can see that Y is a midpoint because we can see that it's separated CB into two congruent parts, and X is a midpoint because it's separated CA into two congruent parts. So when those two are joined together, that segment is called the midsegment. Now there's special properties associated with the midsegment of a triangle, and let's take a look at a sketchpad activity to explore a bit more. In this sketchpad activity, I have a triangle drawn here. Now, if we construct the midsegment, DE, I notice that as I move the triangle around, it appears to be in the same direction of that. And it appears that it's going to be parallel to it. It doesn't seem to move from that parallel line with CA. And we can justify this by taking a look at the slopes. And although they are in decimal form, we can easily identify that the slopes stay the same. So we notice that the midsegment of a triangle is parallel to that third side. The other property of it has to do with the distance. So the distance between points D and E and the distance between points A and C. Right now you might not be able to take a look at, notice the relationship right away, but if we move this so that we're dealing with whole numbers, you might more easily be able to identify what is going on. So if I could almost make this be 3, we notice that ED is 3 and CA is 6. 6 is twice 3. If we move it a little bit more to 4 and 8, we notice the same thing happens. So we can say that AC is twice the amount of our midsegment DE, or in other words, you can say DE, our midsegment, is half as long as the third side. So returning to our notes, we can take a look at the midsegment theorem. And the midsegment theorem says that the segment connecting the midpoint of two sides of a triangle is parallel to the third side and half as long. So from that, based off of this diagram, we could say that AB is parallel to XY, or in other words, the slope of XY is going to be the same as the slope of AB. What we can also say is that XY is half the amount of AB, or you would need to have 2XY to equal 1AB. So let's try some practice problems. We are asked to show that MN is the midsegment of JKL. When you have a problem like this, especially in terms of coordinate geometry, you're going to want to plan it out. Well, if it's the midsegment, it's going to have those properties we just learned about from the theorem. So we're going to want to be able to say that the midsegment is parallel to the third side. And we can do that if we find out that they have the same slope. So we're going to use the slope formula for that. What we're also going to want to do is to say that the midsegment is half as long as the third side. If that's true, then we can say that it's the midsegment. And to do that, we're going to need to use the distance formula. So let's go ahead and try that. So we want to show that MN is the midsegment of triangle JKL, and in order to show that it's parallel to the third side, we're going to want to find the slope of MN, and we're also going to want to find the slope of JK. The slope of MN, we will use the slope formula, and we find out that the slope is -3/2. If we find the slope of KJ, we'll find that it's also -3/2. So we're halfway there. We know that both of them have the same slopes, so those segments are parallel. And that's good news. But we also need to show that MN is half as long, or in other words, KJ is twice as long as MN. So in order to do that, we need to use the distance formula. So when we calculate the distance between points M and N, we find out that the distance is √13. And it's okay to leave it in this term as long as you can identify if it's going to be half as long as side kj. When we find the distance between points k and j, we find out that it's square root of 52. And it's a bit difficult from this to tell if it's exactly going to be twice as long, or if it is going to be twice as long as mn. So looking at this, I see that mn is equal to root 13, and this is already simplified. But I think I could do some more to root 52 to simplify it. And we can see that work here. So if I factor square root of 52, I can find out that its roots are going to be 2, 2, and 13. And when I simplify that radical, we see from this that the square root of 52 can be simplified to be 2 root 13 or 2 times root 13, which is good because that means that kj is twice as long as mn. So with these two statements, we're able to say that mn is the midsegment of JKL. Another and possibly simpler problem that you would have to do involves just identifying midsegments and properties of midsegments. So in applying them. Here we're told that AB is the midsegment, and it's going to be a midsegment, and the third side that matches up with AB is going to be XZ. And that's always a good thing to mark in your diagram so that you don't get mixed up. BC is also a midsegment, and the third side that corresponds with that midsegment is XY. And they ask you to find the measurements for XZ and BC. So we know that the midsegment is parallel to, and it's going to be half as long. So if we have XY is 28, then BC is going to be half of that. So you simply need to divide 28 by 2. And we can find out that BC's measure is going to be 14. Similarly, we could do the same thing for the other side, and here we're trying to find what XZ is. Now we need to be careful here because in this one, we're actually given the midsegment. And we know that the relationship between the midsegment and the third side is this third side is going to be twice as long. So this time around, you're going to want to multiply the value of the midsegment by 2. So 2 times 28 will tell us that XZ's measure is going to be 56. And that is pretty much it. So it's time for our joke. And the joke is, where do snowmen keep their money? They keep their money at the snowbank.